This is lesson 4-7, piecewise functions. Some review of some definitions. An interval is a set of numbers for which we observe, graph, and evaluate any function. Here's some examples to talk about. First of all, the first example, x is less than -1, means all numbers that are less than -1, with -1 not being included. X greater than 1 means all the numbers that are greater than 1 with 1 not being included. X is greater than or equal to 2 would mean that all the numbers greater than or equal to 2 with 2 included. Likewise, with x less than or equal to -5, with all numbers less than or equal to -5 with -5 included. And the last example is a singular inequality where x is between 0 and 6, with 0 not being included due to the fact there is no bar underneath that first inequality sign. However, 6 is included due to the bar being underneath the second inequality sign. A piecewise function is any function with multiple subfunctions, each with a different domain, usually expressed in an interval, an inequality interval. So what do piecewise functions look like? Here's an example of a piecewise function. It'll start out with function notation, typically with f of x, and it will have a curly brace noting that it has multiple pieces. How this reads is that for any value where x is less than 0, we're going to use the function f of x equal to -x. For any value that's x, where x is greater than or equal to 0, we'll use the function f of x equal to x. Piecewise functions are either evaluated or graphed, or can be both. Here's how we evaluate piecewise functions. Determine which piece of the function that you should be using based on the number that's given to you for x. Use that piece to find a value for the function. Here's an example. Let's evaluate the following with this piecewise function. For f of -3, we'll use the top piece because -3 is less than -2. So for f of -3, I'll simply plug in -3 in for x, and then evaluate that piece. -3 times -3 is a +9, minus the 5, which would give me 4. So f of -3 is equal to 4. For f of 4, I'm going to use this piece because 4 is greater than or equal to -2. So for f of 4, I'll be doing 2 times 4 squared. Evaluating that will be 2 times 16, which will give me 32. So f of 4 is equal to 32. Here's an example for you to try. Evaluate those three. Evaluate f of -4, evaluate f of 0, and evaluate f of 5. Pause the video at this point to give yourself a chance to try it on your own. For f of -4, I want to use the top piece because -4 is less than -2. So for f of -4, we have -6 times -4 plus 1. -6 times -4 is a +24 plus 1. So f of -4 is equal to 25. For f of 0, we'll use the middle piece because 0 is in between -2 and 2. So for f of 0, we're going to have 0 squared minus 3. That gives me 0 minus 3, which is -3. So f of 0 is equal to -3. For the last piece, f of 5, I'll use the bottom piece because 5 is greater than 2. F of 5 will be equal to 5 minus the 8. So f of 5 is also equal to negative 3. Graphing piecewise functions, the first thing we have to talk about is what a point of discontinuity would be. The point of discontinuity would be the point on the graph where the graph will change from one subfunction to the other. A point of discontinuity will be open when the value is not included and closed when the value is included, similar to what we did with number line graph inequalities. To graph a piecewise function, the first thing you want to do is create tables for each of the given intervals and functions. Make sure you start with your points of discontinuity and make sure you choose open or closed depending on the inequality sign. Make sure that you're moving in the direction of the inequality sign. Plot your points on the set of axes and connect dots when necessary, but be sure to watch out for points of discontinuity. Let's take a look at an example. So here's a guided example that I will do with you. Pause the video at this point to at least write down the example. So this piecewise function has two pieces. The first piece I'll do in red. That's for x less than negative 2. The first thing I want to realize is that negative 2 is not included in this particular piece of the function. Therefore, I want to remind myself that negative 2 is going to be an open circle when I graph it. Typically, what I'll do is I'll just write an open circle next to the negative 2. Now, if that bothers you because it looks like a 0 from there, then don't bother to do it. Maybe move it to the outside. That's your choice. From here, I want to fill in the x value for the top piece. So I have negative 2, minus 2, which then this is going to be 0. I can also use the graphing calculator to fill in all of my spots as well. This will be 1, this will be 2, this will be 3, and this will be 4. So now I'll use my first table and I'll graph the points. At negative 2, 0, I need an open circle because it is an open point of discontinuity. Negative 3, 1, the rest of them will be closed circles. At negative 4, 2, negative 5, 3, and negative 6, 4. At this point, I'll draw a line in that direction. And I'll continue out the rest of the way. Now, I'll work with the second piece of my function. I'll do this one in black so that they contrast. Remember that this includes negative 2. So this is going to be an open circle for this piece of the function. Now I'll evaluate all of these. So we have 2 times negative 2 squared and that will be equal to 8. Now I'm just going to fill in the rest of these numbers. Again, using my graphing calculator. So now I need to plot these points. So I'm going to go to negative 2, 8, which is up here. And that is going to be a closed circle. Negative 1, 2, 0, 0, 1, 2, and 2, 8. Now I'll connect the dots, and this is going to be a curve And I'm only going to put an arrowhead on this side of the graph because for that piece of the function, x has to be greater than or equal to -2. So the arrowhead only goes on that side of that piece of the function. Here's an example for you to try. This one is 3 pieces. Pause the video at this point to give yourself a chance to try it on your own. First, we want to attack the charts that we've created. So we'll start with x being less than -2. Notice, first of all, this is going to be an open circle at -2. It's going to be -3. And then we have -5, -7, -9, and -11. So we'll first start with -2, -3 being an open circle. And then we have -3, 5, -4, 7, -5, 9, and -6, 11 will be off the graph, so it's okay to leave it alone for the time being. We'll draw this out, and we'll put our arrowhead on the end of this. For the middle function, I'll do that one in red. That's going to be x squared minus 3. Filling it in from my graphing calculator, we have 1, -2, -3, -2, and 1. Both ends are going to be closed circles because they are inclusive of -2 and +2. So now we'll graph these points. -2, +1, -1, -2, 0, -3, 1, -2, and 2, 1. Now I'll connect this in a curve, but I will not put arrowheads on either one. This is a very restricted domain between -2 and 2 included. Now the last one, I'll go back to black, and we will do 2, 3, 4, 5, and 6. So we have, when we plug it in, -6, -5, -4, -3, and -2. Notice we're going to have an open circle for this particular piece. So 2, -6 would be right here. 3, -5, 4, -4, 5, -3, 6, -2. We'll draw it out. And we will have an arrowhead at the end of this one because it will go on forever as x is greater than 2. If you're having any issues with any portion of this lesson, please make sure you are emailing me or consulting me in class.